Imagine gazing up at the night sky, knowing that not far away, at least by cosmic standards, there's a star with a planet that could create a life. Not a distant fantasy, not a sci-fi movie plot, but a real place. And yet, as close as it is, we can't reach it. Not now, not soon. This isn't just any star. It's Proxima Centauri, the closest star to our Sun. Astronomers have confirmed that orbiting it is Proxima b, a potentially habitable exoplanet. This rocky world may have the right conditions for liquid water and, just maybe, life itself. For scientists, dreamers, and futurists, that makes Proxima more than a point of light in the dark. It's a target, a long-term strategic objective for the survival of humanity. But here's the catch. Even with all our current knowledge and technology, actually getting there is beyond challenging. It's almost impossible. And the reasons why reveal a staggering truth about the limits of human space travel. Proxima Centauri lies just over 4 light-years away. In cosmic terms, that's right next door. But in human engineering terms, it's the equivalent of seeing a lifeboat on the horizon while stranded in the middle of the ocean and realizing you have no oars. Humanity's farthest reach so far? The Moon. 384,000 kilometers away. Beyond that, we've sent robotic emissaries like Voyager 1, launched in 1977 and now traveling at 17 kilometers per second. At that pace, it covers roughly 540 million kilometers per year. That's fast by our standards, but to get to Proxima Centauri, it would need 76,000 years. And it's not even heading that way. If we wanted to make the trip in a single human lifetime, we'd need speeds at least 10,000 kilometers per second. And even then, it would take 130 years. At 25,000 kilometers per second, the trip drops to 50 years, which sounds more realistic, until you realize we are nowhere near achieving that. The rockets that got us to the Moon, the chemical kind, are completely out of the question for interstellar travel. Even to hit just 1% of light speed, we'd need a fuel mass so absurd it's almost comical. Over 1,000 trillion kilograms of propellant for every kilogram of spacecraft. That's more than 100 times Earth's mass in fuel. Clearly, it's not happening. So to have any shot, we need new propulsion methods, radically different ones. And we'd probably have to start small. Forget sending humans. A crewed mission would require colossal resources, life support, and decades, maybe centuries of travel. Robotic probes are faster, cheaper, and can take more punishment. And we might also need to lower our ambitions for a first attempt. Instead of orbiting or landing, a high-speed flyby could collect valuable data and images during a single pass. It's not the full dream, but it would be a monumental leap forward. Already used in missions within our solar system, these engines provide continuous thrust for months or years, making them far more efficient than chemical rockets. But efficiency isn't the same as speed. Even at their best, it'd still take tens of thousands of years to reach Proxima Centauri. Here, a nuclear reactor heats a propellant like hydrogen and blasts it out for thrust. It's powerful for in-system travel, but still too slow for interstellar distances, over 40,000 years for Proxima. Developed by former astronaut Franklin Chang Diaz, this advanced plasma engine could shorten Mars trips from 18 months to just 39 days. Impressive? But even so, Proxima would still be 2,200 years away. This Cold War idea involves detonating hundreds of thousands of nuclear bombs behind a spacecraft, with a shock-absorbing plate converting the blast into forward momentum. Using nuclear fusion instead of fission, it could, in theory, cut travel to 150 years. That's slow for us, but within the realm of a generation ship, where multiple human generations live and die before arrival, still, the engineering scale and cost are almost unimaginable today. Contrary to the name, they don't catch solar wind but are pushed by the pressure of light particles. A huge, ultra-light reflective sheet unfurls in space, slowly accelerating as sunlight pushes it outward. This works, but not fast enough alone. Even with an enormous sail near the sun, we're talking 1,000 to 2,000 years to Proxima. Still, sails could be paired with other methods for greater speed. This 1990s design flips Project Orion on its head. Literally, instead of a solid plate, it uses a massive sail in front of the craft, catching the blast waves from controlled nuclear explosions behind it. This could, in theory, achieve better acceleration and reach multiple nearby stars in sequence. Now we're talking cutting edge. Instead of sunlight, the sail is pushed by extremely powerful laser beams fired from Earth or space. If you had a laser array generating 25 gigawatts and a craft weighing just 100 kilograms, you could, in theory, get to Alpha Centauri in 40 years. That's less than Voyager's travel time so far, and Voyager hasn't even left the solar system. The downside? You need the lasers running non-stop for decades, and your spacecraft would have to be extremely light. Among all these ideas, Project Starshot, part of the Breakthrough initiatives, is the most realistic in the near term, and it's actually in early development. The concept launched thousands of gram-scale probes called star chips into orbit. Each one has a tiny camera, sensors, and a thin reflective light sail. Then from Earth, fire an array of high-power lasers at them, pushing them to 20% of the speed of light, about 60,000 kilometers per second. At that speed, they'd reach Proxima Centauri in just 20 years. Add 4 years for the signals to return, and we could have close-up images and data from an alien solar system within our lifetime. Each probe would be vulnerable to collisions with interstellar dust, but sending thousands at once means some would almost certainly survive the journey. The beauty of the plan is its scale. Tiny, inexpensive units instead of a single megaship. If even one star chip made it, it could capture high-resolution images of Proxima b, revealing whether it has oceans, continents, an atmosphere, or any hint of habitability. We could analyze its chemical makeup, search for potential biosignatures, and even map its weather systems. It would be the first time humanity had directly explored another star's planet. Even if we found a barren rock, the scientific value would be enormous. As Carl Sagan once said, the day we reach other stars, humanity will no longer be the same. Such a leap demands wisdom, cooperation, and technological mastery. The journey to Proxima Centauri isn't just about curiosity, it's about survival. Our sun won't last forever. The Earth won't stay habitable forever. If our species wants to endure for millennia, we need to think beyond our solar system. Reaching Proxima isn't just a dream. It's a first step towards becoming an interstellar civilization. The technology isn't quite there yet, but the vision, determination, and ingenuity already are part of who we are. The question is no longer, can we do it, but will we commit to doing it? If you believe humanity's destiny lies among the stars, support the science, share the vision, and push the conversation forward. Like, share, and subscribe for more deep dives into the technologies, challenges, and wonders that will shape our cosmic future. Because somewhere out there, under the light of a nearby sun, another world is waiting for us to arrive.